Here's question 1. We're going to use the sine, cosine, and tangent, what each of them equals, in order to figure out equivalent expressions and how each of the ratios can relate to each other. So this is asking us which expressions are equivalent to tan of angle R. So let's look at angle R and figure out what is tangent of R. So if I'm looking at R here, this would be opposite, this is adjacent, and this is hypotenuse. Tan of angle R would equal, we look up here, tangent is opposite over adjacent, so that's side PQ over adjacent is PR. So PR. So I see PQ over PR, right there is one answer. Boom. Tan of Q is not going to be the same as tan of R because they'll flip the two around. So I can rule out D. So I know it's either going to be one of these that deal with Q. So let's look at angle Q. I'm going to go ahead and erase these. Let's look at angle Q. Opposite, adjacent, hypotenuse. We want the ones that's PQ over PR, so that would be adjacent over hypotenuse, or sorry, adjacent over opposite. So we want A. All right. Question 2 says, which expression represents the length of side BC? So we're trying to solve for this x. It looks like they're using sine of 35 degrees, sine of 55, cosine 55, cosine 35. So we know that one of them is going to be sine and one is going to be cosine. So once we find whether 55 or 35 works for sine, we'll know that the opposite one will work with cosine because their opposites are equal, sine and cosine. So let's try setting one up for sine of 55, and if 55 doesn't work, then sine 35 has to work, which would mean the opposite cosine one would work. So looking at angle 55 here, oops, sine would be opposite over hypotenuse. And we see sine is not going to work with 55 because opposite is the AC sine. Cosine of 55 would use the adjacent. So cosine of 55 is going to work, which would then mean that sine 35 would work. If I look at side A, opposite would be here, hypotenuse. So sine would be the x side, which is what we need. All right, question number 3 says, Aubrey tried to prove that sine of theta just means an angle we don't know, is equal to cosine 180 degrees minus theta using the following diagram. Her proof is not correct. We want to figure out where she went wrong. Well, step 1 says measure of angle C, so this angle, equals 180 degrees minus theta. And right there is where there's an issue. If it is not 180 degrees minus theta, it should be 90 degrees minus theta, because all triangles add up to 180 degrees and angle A is 90. So that leaves angle C to be 90 minus theta to make up the other 180. Which means that angles B and C are complementary, not supplementary. Complementary means add up to 90. Supplementary means add up to 180. So our answer is A. And I don't really have to look any further in the proof. All right, last one. Question 4. Consider right triangle MNO below. Which expressions are equivalent to cosine of M? So let's figure out what cosine M is. Opposite, adjacent, hypotenuse. Cosine is adjacent over hypotenuse. So that means this equals MO over MN. So we can mark this one. And we need to figure out which one of these others also equal MO over MN. Let's just try B. Well, we know it's not going to be this one, by the way. And honestly, we know it's not tangent either, because tangent doesn't use the hypotenuse, and we need the hypotenuse. So really our only option is this one, but we can double check it. If I look at angle N here, opposite over hypotenuse, its opposite side is MO over hypotenuse MN. There you go. Have a good day.